Now that the build season has begun, the team meets every day after school from 2:30 till 8. Team meetings usually start with the whole team coming together to discuss what the day's meeting will focus on before the team breaks off into organized sections such as mechanical, electrical, and programming. Meetings for the first week are still in the planning phase, in which the team will come up with basic ideas to be presented before finalizing any plans for the next phase of the building process.
So we started thinking up designs, turrets, conveyors, launchers, all sorts of crazy stuff. Well, we made cardboard or foam board models of each of the ideas. The two big ones were a conveyor idea, which had two conveyor belts running in opposite directions, which would suck the moon rocks in, and then they'd reverse to push them out at the desired height into the baskets. The other idea is to use a similar system to pull balls up to a turret, which would then use the camera to locate other teams' trailers and launch the ball the proper distance and height into their trailer. And I think we finally settled on a turret design.
The team begins work on the basic frame of the robot. They also have to construct things such as the trailer that the robot tows. Of course, FRC is not just about robots. The team also has to put together an animation and upkeep a website.
The animation this year is on biomimicry, using life and meaningful strategies to solve problems that we have on Earth. So pretty much we have to use a real-life issue to design and make a problem to solve it, such as turning CO2 into helpful oxygen. And I have 4+ people working on it, plus a mentor or two, depending on when they come. Well, today we're purely storyboarding and throwing ideas up, and I'm taking pictures of what ideas we did put up on the board. Then probably tomorrow and Thursday we'll continue with storyboarding and seeing what idea we want to do. And then once we figure out the idea we want to do, we can go ahead and start animating.
The website serves many purposes.
Communications tool between the team, and it's also a way for people who aren't on the team or aren't around here to be able to find out more about our team, and sponsors to be able to find out more about our team.
Spinning.
Now that the team is settled on a design, they move into the blueprinting phase in Autodesk Inventor. Once the frame is constructed, the drive team attempts to drive on the new low-friction surface that will be covering the field. The team also needs to practice driving with the trailer attached to the robot.
That's high speed right there.
Yeah. Yikes. Oh no. Heck, the back on.
The wheels are slippery and the floor only adds more to that, so it's a lot harder to control the robot where it's going. Also the trailer, it makes it so that your turning is a bit more limited. It was sort of what I expected. A bit slippier than I thought it was going to be, but I think we'll be able to do fine. It can go pretty fast once it gets going.
The team begins construction on full-size prototypes and meets with sponsors to see what parts are available to construct their machine.
Static, they're not going to move at all, right?
Right.
Or, well,
No, these would...
I am working on the turret with our mentor, Doug, and we are going to use a motor to turn it 360 degrees around, and then we're going to use a sim motor with some high traction wheels, put that in the middle, and that's how they launch them. And it's all going to be automated with the camera.
The idea is that this whole assembly will be mounted on probably a Lazy Susan bearing from a large Lazy Susan. Then balls will feed up from below, get pinched between this roller and here. So you have a constant distance here until you get to here. Take off at a 45-degree angle, which theoretically gives you the optimal trajectory, meaning the furthest reach. And hopefully it'll be consistent.
come over here, Rob, come over here, hold here. The idea is it's going to look something like this, okay? Ball's going to come in, Okay, you got this? Okay. This is gonna turn, gonna take,
In week 2, we finalized our designs for the mechanism that picks up the ball and the turret. We have prototypes for both of those, and we are in the process of ordering parts from various companies. Hopefully those parts come in this week and we can start building them.
While the team waits for their parts, they get into some much-needed human player practice. But once those parts arrive, the team goes into overdrive to get the robot finished before the 6-week deadline. The robot is completed by the beginning of week 5, so the team has plenty of time to get in some driving practice. The turret on top of the robot not only has the planned full range of motion, but can shoot at a distance of up to 10 feet. At the end of week 6, the team loads the robot up into the crate and ships it out. The team has about a week of rest before going competition.